Thank you guys. Thank you.
Well, you figuring everything, I'm walking along. On that side, only because. I'm not so real proud, but. Well, I was getting better. It's hard. You know. Once you get in there, you get better.
Yeah, so we're talking about vitamins again today. If I can get this working. So, Morrisville Thanksgiving Project, some of the professors are helping serve the local community. We've kind of taken the dairy products under our wing, under the leadership of Professor Marshall. If you would like to contribute to that, she needs the money by today. Lab tomorrow will continue on with lactating rations. Please bring your laptops as you'll have to run spreadsheets in Microsoft Office is the plan. So we're going to continue on with vitamins today. We're going to talk about the life cycle of a cow, how where she is in lactation influences how we balance rations, what we try to achieve, what we need to be concerned about. Next week we'll do probably finish up vitamins and get into feeding cows. Feeding cows will be our last week of lecture, and then lab practical will be our last lab. The third exam for this class is scheduled for Wednesday, December 7th, 10:40 here in this room. It should be about the same size as previous exams. So dry matters, everybody ready for those? Ready? Okay. So I'll make sure those buckets get put on the tractor so you have samples tomorrow morning. So with the snow, it's something we need to get on. Cheyenne, do you have a particular day during finals week you would like to do this? Any day you want that week.
Earlier.
Okay. So take a look at your schedule, let us know what day you want to select, and we'll pick it from there. Okay. So back it up a little bit about vitamins. We talked about bioavailability with the minerals. One thing we have to consider in addition to bioavailability or bioactivity with vitamins is whether they can be created or destroyed, particularly within the rumen. So what consumed versus what is absorbed? The first thing that happens, it goes to the rumen. A lot of the vitamins that end up there are destroyed, but we also have production of vitamins that we'll get to here with the water soluble and vitamin K. So then you've got whatever leaves the rumen can be digested or absorbed. And another thing to think about with vitamins is that the actual final form or actual final configuration will influence its function. So if we take a look at, no, not just yet. International units, I didn't give you a definition of that last time. It's a standard reporting unit associated with vitamins, and it's based on a biological response. So it's not necessarily related to the amount, it's related to the activity. And it's not perfect, but it gets there. And again, the differences in vitamins, what happens to them in the body will influence that final measurement that we get. So minerals cannot be created or destroyed in the body. vitamins, particularly in the rumen, can be created and destroyed. That makes things a little bit more complicated, just like when we talked about protein nutrition. What happens in the rumen adds a layer of complication. So we're looking at hundreds necessary for vitamins A and D. We're going to have a lot less than that for other vitamins. So I didn't show you a picture of vitamin A last time. Top three things there are forms of vitamin A. So you've got that yellow, that's a hydrocarbon circle, that hexagon there, and you've got a tail with double bonds coming off it. That is the active form of vitamin A up top and various activities related to that. We said the precursor is beta carotene. And I did mention that if you split that in half, you basically get 2 vitamin A's. I'm just illustrating that, showing that to you. So beta carotene, basically if you cut it in half, you're going to get 2 retinols, more or less. So that pigment, that color, becomes a vital nutrient for the animal. We didn't talk about bioavailability. Some is destroyed in the rumen. This is stuff coming out in 2021. There's no data on the absorption of rumen, intestinal absorption of ruminants. Nobody's going to pay for that study. So most of the absorption work has been done in rats and small animals. For cows, you never know what's going to happen. There may be a maximum that can be absorbed in a given day. We don't know. Or the amount absorbed might be modified by status. We certainly see that with calcium. The greater the need, the more absorption of calcium we get. As we get to overload with calcium, you'll see the absorption rate back off. And another thing we didn't mention last time is stability. As feed sits, as it's conserved and stays for a while, that vitamin A activity goes down. So the longer you have something stored, you're going to lose the international units available in that feed. So this is the newest stuff from 2021. The stuff that was published this year, the book. So this brings up something we're going to see over and over again in vitamin nutrition. Requirements pretty much can't be established. We know exactly what we need to feed to make everything happen. So what the NRC did is a lot of things we have requirements for, but vitamins, we have what's called an adequate intake. If we feed this much, that should get the job done. But is that exactly what they need? No. We don't have any basis for that. So they went with a phrase called adequate intake. And under that, they assume that the feed does not provide anything. That we need to do everything through supplementation. So the adequate intake is based off of supplementation. Added vitamin A in the grain, in the salt blocks, or wherever you're going to put it. That doesn't account for all the vitamin A that might be in the silage, that might be in the hay, any of that. So they added this time around with the NRC, the first time in 20 years, that additional should be provided for animals over 35 kilograms, over 75 pounds of milk. So putting more in. And they also noted that there's a toxic level that 6 to 12 times the adequate intake usually leads to signs of toxicity. So you have those concerns with the fat-soluble vitamins, particularly those that are stored in the body. If you overdo it, you can lead to some problems. Vitamin D, here's vitamin D2 and D3. I didn't show you those pictures last time. So slight difference between the two. You've got that methyl group present on this molecule, the D2. As we go over to here, that CH3 group is removed. So small differences have profound differences in the effects on the activity of the animal. Although the NRC talks about there's no real difference that they can find in dairy cattle for D2 and D3. So we talked about the cascade or alluded to it. So this is how it all happens. You've got things being made in the skin under the influence of UV light. Those things are modified to D3. You also have intake of vitamin D, vitamin D2 from supplements, vitamin D3 from fish and meat. All of those go to the liver, slightly modified. Final step is in the kidney to get that active form ready to go. So different molecules, different parts of the body, the chain of what's happening through. So I think we missed a few of these at the end. So my damn legs, D, don't work the way they used to. Vitamin D, big and strong. Vitamin D, we've got some big bones, strong bones. We've got complete, not wholly bones. So vitamin E, we have a group of tocopherols and tocotenols. We don't really care. We're going to put it under the group of vitamin E. You want to see what this group looks like, that's it. So all have that double circle, double hexagon at the end, and they got a chain sticking off there. The alpha tocopherol is the most active, the most potent form of that, but all of these have vitamin E activity. So again, small differences can influence how we go together, and I will never ask you to draw that. I had to do that in college. That was not a lot of fun. The function of vitamin E is an antioxidant. And that's going to hopefully, on a macro level or a practical level, it's going to help us prevent retained fetal membranes or retained placenta. It's going to help us prevent mastitis. So we know that the most likely times for mastitis are dry off and freshening, given that the cow isn't quite used to everything happening. So supplementing our dry cows with vitamin E and selenium seems to be a good thing to do. So we reduce those fetal membranes, we reduce the chance of mastitis causing a problem. So functions, we have that antioxidant. That is kind of overlaps with the support of the immune system. So anytime we have an infection, anytime we have some problems, vitamin E supplementation seems to help. So mastitis, retained fetal membranes, metritis are all indications of some sort of lack of immune response. If we can support that immune response with vitamin E, and there seems to be a weird interchange between selenium and vitamin E, that if you lack one but increase the other, you get the same net effect as if you had like a 50-50 mix. They seem to be able to replace each other for whatever reason, and that doesn't make any sense at all if you think about you've got an atom over here with a charge on it versus that big organic molecule. But they seem to be able to replace each other, and then we tend to supplement them together in the mu-C injections. So getting back to our source, vitamin E is a plant origin. Lots are in live plants. but the amount decreases rapidly in dead plants. So vitamin D, if we keep the sunshine on that hay, might it go up? Vitamin E will disappear rapidly as that color goes away. So our source, as with most of our vitamins, we go to those green plants. Eat your vegetables, right? So vitamin E, absorbed with fat, stored in the liver and the adipose. It's a fat soluble vitamin. It's going to tend to move with the fat. So the adipose or fat tissue in the body is going to have lots of vitamin E. It's also going to be stored in the liver for when it's actually needed. So you're not going to have the stores that you will with vitamin A and D, but you should have enough to get through the winter, is the hope. Our main concern is the newborn and the young. They haven't built up their reserve yet. So certainly there'll be some transfer with the fat and the milk, but we usually try to supplement those animals, try to give them a boost with that injection at birth. Some places will do that, giving that MUC injection there. If we don't have enough or we run short on vitamin E, we'll get white muscle disease in calves. Also called nutritional muscular dystrophy. That's different than the neurological muscular dystrophies, but same outward appearance. So white muscle disease, if you look at those muscles under a microscope or even just cut them open, you're going to have white muscles where you expect something darker, red, and you're going to see something that's kind of oozing. Exudative is, I believe, the word they use. So requirement for ruminants has not been established. So we focus again on adequate intake. How much do we have to make sure that we're mostly right? So again, you're not using what comes in the feed. You're only focusing on supplementation, not the total provided. So how much supplement do I have to give this animal to make sure she's covered? And kind of implied in that is maybe some of the intake in the feed is helping things be adequate. So generally with ruminants, the only vitamins we worry about or add to their diets are A, D, and E. And we're looking at adequate intake. So the idea behind trying to figure out a study for this would probably be $250,000 to $500,000 to figure this out. And there's no money in that, somebody figuring that out. So nobody's going to pay for that or provide a grant for that study. Gone are the days where the government would just fund studies to help farmers get better. That went out in the 70s. It's why we are one of the best agricultural countries in the world, when the government used to support, but there's so few people in farming anymore directly. They're not going to support that part of the population preferentially. So vitamin E, we're looking at probably 100th of the international units that we were dealing with A and D. So you're going to give 1.6 to a dry cow per kilogram of body weight. You're going to get 3 to close-up cows, trying to help them through that transition period, the last 3 weeks of gestation. All others, it's suggested that we stay at less than 1 international unit per kilogram of body weight. So that goes all the way from calves all the way through lactating cows. The only ones we're going to give a little boost to is our late gestation animals. So body weight and pregnancy stage or stage of pregnancy is what determines or what we use to calculate that adequate intake. So where is she? The last 2 months of gestation, 1.6. Last 3 weeks of gestation, 3.0 is our hope to get to that animal. But the question is, are we doing something different in those last 3 weeks that would allow us just to feed that extra just to those close-up animals? So again, I won't ask you to remember those requirements. That's what ration balancing formulas are for, and that's what nutritionists are for. But we're going down, for the most part, less and less for each of the vitamins as we go from amount standpoint. So muscular dystrophy in a sheep, animals not able to walk, legs are not working the way they should. Stiff lamb disease is another name for it, white muscle disease. Unable to stand due to tissue degeneration. We don't have the antioxidants there. The oxidants are taking over the muscles and destroying those muscles. So the free radicals and all that stuff are making things bad. We also have an animal here, bovine, that can't stand up and suspected at this point of white muscle disease. So this is the graphic I had to remember this. Muscular dystrophy, so vitamin E and selenium seem to prevent that. Some other ones from other students. I think I'm starting to get white muscle disease. Quick take some vitamin E. Retain fetal membranes from a lack of vitamin E. I probably should take some kale so I don't end up like this. So preventing mastitis. Does everybody see what the person did there? Morrisville gang sign, 3 fingers down, right? Right, there we go. I prefer the 3, but it's same net effect. So 3, we've got that E there on the udder, kind of subtle. The last fat soluble vitamin we'll talk about is vitamin K. It's required for blood clotting. We need this, and that's sort of where the letter comes from. The German word, where Germany was where a lot of this initial work was done. Clot begins with a K. Like my grandfather, Carl Berkner. Carl with a K. He got massively offended if you tried to spell it with a C. So we need vitamin K for blood clotting. We need it to make certain proteins. We know it's available in green plants, but it's also synthesized in the rumen. So we can generate it from nothing if we provide enough nutrients for our microbes to grow. We'll get enough vitamin K synthesized in the rumen to cover our needs. So does anybody know the relationship between vitamin K and the main ingredient in rat poison? Warfarin. Has anybody ever heard of warfarin? Does anybody have a relative on warfarin to prevent blood clots? Our manager up here at the dairy used to be on warfarin to do that. So warfarin is anti-vitamin K. It's also the main ingredient historically in rat poison. So warfarin is going to prevent clotting. It's going to interfere with the action of vitamin K. So if a rat or a mouse ingests warfarin, how does it die? Does something with the blood. No, it's the anti-vitamin K. So the problem is they basically bleed to death through internal hemorrhaging. That's why a lot of times you're going to find those dead rats and mice near a water source. If you have a rapid loss of blood volume, you get tremendously thirsty very, very quickly. So warfarin is anti-vitamin K. It basically negates all of the effects of that. And as rats, rats can pretty much squeeze through all kinds of holes and stuff. As they do that, they start rupturing capillaries if they got enough warfarin in their system, and then they bleed to death. So that's how rat poison historically works. Some of the new things do some different things, but that's still a main thing. At least the dead mice in my house are usually heading toward water. One of the drains for a leak in the house. So synthesized in the rumen. As far as we know, vitamin K is again absorbed with the fat. Unlike A, D, and E, there is very little storage in the body. That's probably a good thing for our cows. We don't want to overdo it because if they're manufacturing it, there's probably no reason to store it. So a healthy cattle do not lack. As long as the rumen is functioning properly, they've got the intake, we're getting the mixing, we're getting the fermentation, we're getting the absorption. Healthy cattle are not going to lack vitamin K. So that's the reason it's not included in that A, D, and E for additional supplement. Made in the rumen, if the cow is healthy, there shouldn't be a problem. So this is the diagram I had. So K is for clotting, what the thing does. So we had, what do? I can't stop. It won't stop bleeding. So L is having trouble. We're getting vitamin K on our Band-Aids there. So K on the Band-Aid there to get things controlling. So we're ruining our good grass. So we got Band-Aids, the shape of a K that helps stop the bleeding. So those are our fat-soluble vitamins, A, D, E, and K. So we just generally supplement A, D, and E. We'll move on to the water-soluble. We're going to focus on the two different ones, and then we'll do the B vitamins as a group. So C is an antioxidant. So what antioxidants do we have in nutrition so far? Which mineral? Selenium. Which fat-soluble vitamin? E. And now C. So antioxidants are very important in the body. You'd think they were even more important based on some of the commercials you see. So oral supplementation, all that you'd feed to a cow would be destroyed in the rumen. So oral supplementation, there hasn't been much research, so we don't have any strong conclusions. And we do know that the cells after 3 weeks of age will produce all of the vitamin C that the animal needs. So we don't usually worry about vitamin C for our ruminants. We hope that mom is producing enough. It gets passed through the milk for the first 3 weeks, which it should. After that, the animal can take care of itself as long as it remains healthy. So if you were going to feed it to a ruminant, you'd have to protect it somehow from rumen degradation. So you'd have to form a protected form of that moving forward. And as you will see, that if you read the NRC that came out last spring, current data does not support routine supplementation of vitamin C to calves or adult cattle. So there are people that are trying to sell this to you. They have to prove that it doesn't get destroyed in the rumen and that vitamin C is your most limiting nutrient. I would doubt they can do either of those. So, so that's the current state of research as of the end December 2021, 11 months ago. One of the things that does happen to other animals, particularly carnivores and omnivores, is that we start to get really bad gums. So bleeding gums is a condition called scurvy. And that's not just the general thing there. So you've got the bleeding gums. Scurvy is associated with a number of things, but loss of teeth is a big one. So has anybody heard the phrase limey to describe a British sailor? Got one yes. Anybody else? Limey. So they're called limeys. Back in the 1800s, they found that the sailors that were around or sailed around the South Pacific seemed to do better, or down in the tropics seemed to do better than the sailors that stayed in the northern latitudes. Hardtack in water. Has anybody heard of that? The rations on a ship. Hardtack is this bread-like biscuit that stores well and doesn't mold during shipping, so they store it in a barrel. You got these biscuits that are pretty nasty, but generally they're lacking in vitamin C. They found that the sailors that went through the tropics had access to citrus fruits. And after a while, the Navy, before every voyage, would issue each sailor a bag of limes. And the idea behind that is that's how they got their vitamin C. The limes would hold up probably better or longer than oranges or grapefruits or anything like that. So because of that bag over their shoulder, they got the nickname limeys, trying to prevent their loss of teeth. That's probably not a way you want to go for young sailors. So scurvy, we're going to lose teeth. We're going to have bleeding gums. Bad things happen. So a lot of people went with the pirate themes. I think most of you grew up with Captain Jack Sparrow, right? So you have, when I was a kid, probably being a pirate wasn't cool. Johnny Depp sort of changed that in the last 20 years. So we're trying to prevent scurvy. You've got vitamin C. You got an antivirus. So a lot of people are big proponents of humans consuming massive amounts of vitamin C to prevent illness. I had a friend of mine's father used to do 1 gram a day of vitamin C. So that's like 4 or 5 of those tablets. And I don't get sick. Well, you probably don't get sick because you've been exposed to everything by this time in your life. And you have a regular routine, not like us high schools that students are up all night sleeping late, whatever. You've got a routine, you're probably got better nutrition. There's a lot of other factors in there. But you're going to see vitamin C and a number of cold remedies helping hopefully prevent or reduce the severity of an illness. Choline is another fat soluble or water soluble vitamin. And we're looking at our cows, we're looking at a need for grams per day seems to be required. That doesn't quite fit the definition of vitamin, but we'll still put it in that category. Other species don't need nearly as much. Fortunately, there's lots in the feed. It's going to have enough it'll bypass the rumen. For our calves, it's very abundant in milk. There doesn't seem, if you look at the official research, they don't have a specific requirement for it, but it seems our lactating cows need more. There's some research that suggests that maybe it helps with fat metabolism. So you'll see supplementation in close-up rations and early lactation. As that animal is mobilizing fat off her back, maybe the choline can help process that. We know that supplementation helps our transition cows. It spares methionine. What could that do? What is methionine? Essential amino acids. So if we can spare that, it's often most limiting with milk production. So if we can save that, spare that, have more available for milk production, we should get more milk protein if we feed choline. So we already mentioned fat metabolism. If we look at the newest NRC, they're saying those effects might be small. But there's a lot of people that swear by it, and probably as a preventative, it's not that expensive. Because it is degraded in the rumen, if you're going to supplement it, it needs to be rumen protected. So it'll float around in the rumen, in a case, in a plastic, whatever, that once that hits the stomach acid, it'll be released. You want it to be released in the small intestine where it can be absorbed and put to use. It's thought that a lack of choline leads to or helps foster fatty liver. We're not processing the fat the way we could, and you're going to have that fat being accumulating and building up in the liver. So deficiency sign for our ruminants is fatty liver. So water-soluble vitamin, we got vitamin C, choline, and then we got the B vitamins coming up. Everybody got written down what they want. So this is the diagram I was given as an undergrad. Does everybody understand what that means? I still remember this every time I think of choline. What's happening there? Coal miner. So what are those black dots, black blobs? Bunch of coal, and what are they doing? Leaning. Choline, choline, get it? So we've got choline related to fatty liver. Oh, my fatty liver. It still pops in my head every time I bring that up. So choline, I guess it's probably because it took me so long to figure out what the hell is this picture of? Look, choline. Another creative one that was done by a student was takeoff on the Dolly Parton hit Jolene. Everybody familiar with the song Jolene? So please don't steal my fatty liver. Please steal my fatty liver. So choline, Dolly Parton, Dolly Vitamin Show. Thought that was there. So fatty liver, I should probably take some choline. We have the evil villain here. I will steal all the choline and ketosis will destroy the herd. So Captain Ketosis is going to steal the choline and cause problems. Fatty liver usually leads to ketosis. So we're going to talk about the B complex first together, and that makes the most sense with the ruminants. And then individually, we'll talk about some of the things that are associated with each of the vitamins. So B vitamins, the B complex source is green plants and ruminant microbes. So a healthy ruminant is never going to have a problem with B vitamins. So dietary concentrations vary on things, how much is there, how much isn't there. How the hell do you measure these? They're very difficult to measure. We know as a group they were kind of discovered second, but each of the individual ones were very hard to parse out. Microbes synthesize and degrade. So they're going to create B vitamins in the rumen or anywhere. You take microbes anywhere. What is it? Cyclists in Europe. If you're a competitive cyclist, you're biking 100 miles today. One of the big pre-race rituals is a beer. Lots of readily available calories, very quick, and full of B vitamins. It's a fermentation product. So I guess that might be a way to justify getting sloshed. I'm taking care of my B vitamin requirement. So intestinal absorption, undefined. So we don't know a lot about what goes into the cow, what happens in the rumen, and then what ultimately happens at absorption. So one of the things about the B complex, and this is similar for most of the water soluble, is they're not stored in the body. So vitamin C, choline, all the vitamin Bs are not stored in the body. Therefore, it's really hard to overdo it and get toxic with the water soluble vitamins. Whereas we can do that. It's not that complicated to do that with A and D. Do 6 to 10 times the amount that you're supposed to have, and you'll move into toxicity fairly quickly. So as long as there's enough water in the body, enough water consumed, any excess will be passed out the kidneys. I have a cousin who used to say, well, taking vitamins just makes your urine expensive. So if you don't need those B vitamins, they will pass right out. But the idea is that maybe you do. So the body will take what it needs and gets rid of the excess. When we think about the B complex, we're talking about being involved in reactions in the body, particularly the release of energy, the generation of energy. We'll find them involved in the cytochromes, a lot in the mitochondria. They're involved in generating that ATP that we need to move forward. So again, comment from last December's publication. Book came out in January. Overall, because of analytical challenges and other issues, estimates of the synthesis, degradation, and absorption need to be improved to increase the ability to accurately determine when supplementation is warranted and will elicit a positive response. So how do we summarize that statement from the NRC? We don't know what the hell's going on. We don't know what's being made, destroyed, absorbed. We know it's necessary, we know it's needed, but we can't put quantitative numbers on it. And this becomes the issue if somebody's trying to come and sell you B vitamins on your farm. Show me that my farm needs that. So deficiency is not likely in a healthy ruminant. The rumen should, if working properly, should take care of all the B vitamin needs. The dietary intake of whole grains should take care of all the needs. Should we add, and you'll hear for our lactating cows or early lactation cows, niacin, thiamine, B12. Certain companies will add that to their mix. B vitamins are often not considered in diet formulation and are rarely supplemented because the signs of B vitamin deficiencies are rarely observed in adult ruminants. So we don't know what's going in. We don't know how it's going to change. We really can't balance diets for them. We just want to make sure the rumen is healthy. The rumen is working properly. So what do we have to balance to make sure we get our B vitamins? Carbohydrates and protein. If we get good NDF, good starch, good protein fermentation in the rumen, the B vitamins will be taken care of. Who do we consider for supplementation? Anybody that doesn't have a functioning rumen. So that's our pre-ruminants, our calves. There might be some warrant to do that, especially if you got a sick one, diarrhea. Maybe the injection of B vitamins would help that animal. They're not absorbing anything. There's no storage in the body. Maybe there's an opportunity there. Animals that are off feed. The rumen's not working the way it should be. It's not working efficiently. We know the production of B vitamins is going to go down. The body doesn't store any, so you're going to be compromised there within a very short period of time, 2 and 3 days. If we've got any other compromised rumen function where the fermentation is not going the way it's supposed to, B vitamin supplementation might be a good thing. So when we drench those cows, we tend to add alfalfa meal, which should be high in B vitamins if it's still green. We tend to add B vitamins. We give them that injection, trying to help them out. And the other question is very high performance. If these animals are giving 160 pounds a day, would additional B vitamins help them process the energy necessary to do that? There are some schools of thought that suggest that is the case. If you can target specifically additional B vitamins, what do you have to do with those vitamins if you protect them? They have to be protected in the rumen or be destroyed. So you have to feed them in a protected form, and you have to target the animals with high production because an average production is not going to need them. It's a waste of money to go to them. So maybe with higher animals, we might have there. So we're setting the animal's requirement. We're thinking about what needs to be done. We've got no problems that we see visually, which is what we usually see. But a lot of people are saying we need more for maximum production. That's why I'm coming to this farm and selling this supplement to you. So, any questions on B vitamins? Here's I am out of time, so we'll see you on Monday.
Yeah. And then so. Oh, 10?
Well,
Hey, Vaughn.
good.
Yes.